All right, worksheet 3, questions? Okay. Situation 3. All right, so what's your question on situation 3? Okay. Let's look at well, look at the velocity. Here's how the velocity is increasing. It's negative 16, then it's negative 8. Negative 8 is greater than negative 16. Then it's even bigger and big. You know, it's easier, I think, to look at the graph and see it. That's your velocity graph. It's definitely increasing even though it's negative. Okay? Let's look at the quiz portion of this. If velocity is negative and acceleration is positive, then according to situation 3, the speed is decreasing. If the velocity is positive and speed is decreasing, then according to situation 4, the acceleration is negative. If velocity is positive and decreasing, then the speed is, according to situation 4, decreasing. And if speed is increasing and acceleration is negative, then according to situation 2, the velocity is negative. Now, number 5. If the velocity is negative and increasing, then, according to situation 3, the speed is positive and decreasing. If the particle is moving to the left and speed is decreasing, then, according to situation 3, acceleration is positive. Yeah. Negative instead of, I don't think it has to be decreasing, does it? Speed is increasing and acceleration is negative. Yeah, I guess they could have. Yeah. I expect everybody to put one thing in the blank instead of two. So if you put one thing in the blank that's correct, we're fine. Okay? Does that help for worksheet 3? Where you at? For well, okay, look, this is pretty big here actually. Let me see. After looking at situation 1, situation 2, and situation 3 and 4, here's what we want to figure out. Okay? When the speed is increasing, the velocity and acceleration have the same signs. okay? Because that's from situations 1 and 2. That's where the speed was increasing. The velocity and the acceleration have the same sign. Either they're both negative or they're both positive. And then in situations 3 and 4, that's when the speed was decreasing. And when the speed is decreasing, the velocity and acceleration have opposite signs. Okay? That's something you need to just remember, because this all gets kind of confusing, right? You got graphs, you got derivatives of derivatives of derivatives, and you got graphs of derivatives and graphs of functions, and you got absolute values of some of these things, and it gets confusing. It will help you stay grounded if you remember that if the velocity and the acceleration have the same sign, the speed is increasing. And if the velocity and acceleration have different signs, the speed is decreasing. Okay? So that's what they were wanting you to get at there. And I almost skipped past that accidentally, so I'm glad you asked. But that's a big, I was looking for it in my notes. I knew it was in there somewhere that I needed to point this out. I couldn't find it. So there it is. It's a fairly big deal, okay, with motion. That if the velocity and acceleration have the same sign, that means the speed is increasing. If the velocity and the acceleration have different signs, the speed is decreasing. And it doesn't matter if it's when they have different signs. It doesn't matter which one's positive, which one's negative. It's that they're kind of fighting each other. You know what I'm saying? And that makes the speed be decreasing. So, does that answer your question? Okay. So, remember that. If you know the speed's increasing, you know velocity and acceleration have the same sign. If they have the same sign, you know speed is increasing. Same thing with the decreasing. If the speed's decreasing, velocity and acceleration different signs. If you know they have different signs, speed's decreasing. Try to keep that in your little brain, okay? Because I forget it all the time. But if I can remember that, it just helps me keep a mental picture of what's going on with this object moving back and forth. Okay? All right. Now we're done with worksheet 3. All right, worksheet 4. Take a look at those answers. I felt like maybe I should explain on number 6 why it gives the total distance traveled. Okay? So for number 6, the definite integral from A to B of the absolute value of the velocity, v of t, dt, will give the total distance traveled. Because the absolute value of velocity is speed, so we've turned it into a couple ways I'd like to explain this. But I think my favorite way is by taking the absolute value of velocity, you turn it into all forward motion. You know what I'm saying? Instead of it going to the right with a positive velocity and then to the left with a negative velocity, since we're taking the absolute value of it, think of it as just keep going to the right. It didn't really, but as far as the distance traveled is concerned, think of it all as forward motion by taking its absolute value. Does that make sense? All right, it's also the same thing that we've done a couple times before. You're finding the distance traveled between resting points. Okay? And since you're finding the total distance traveled, you don't care if it's to the right or the left, you just care that it's distance traveled. So absolute value makes it all going in the same direction. So I wrote down that gives the total distance traveled because when the speed function, which is the absolute value of velocity function, transforms all negative velocities into positive velocities, it also transforms all backward motion, motion to the left, into forward motion, motion to the right. Thus, the change in position from start to finish of the resulting forward-only journey is the total distance traveled during the original forward and backward and forward and backward and backward and forward and left and right. Okay? Make sense? Anything else on worksheet 4 you'd like to talk about? Okay. Let me pause for a moment. All right, worksheet 5. This is our last worksheet here in the motion module. And let's do a little bit together, and I want you to do most of this on your own. But the first example starts off with a graphical representation of motion. So it says the graph at the right shows the velocity, v of t, of a particle moving along the x-axis for the closed interval from 0 to 11. It consists of a semicircle and line segments. They tell you that just so that you don't have to guess, well, I think that's a semicircle. It is. Use the graph and your knowledge of motion, and there's the scary part, to answer the following questions. Now remember, this is the graph of velocity, not the graph of the position function. This is the graph of the derivative of the position function. And also remember, this is not the graph of acceleration. This is the graph of the antiderivative of the acceleration. Okay? So, at what time, t, between 0 and 11, is the speed of the particle the greatest? All right. The speed of the particle is greatest when t equals 8, because that's where the absolute value of the velocity is greatest. Okay? It's not the, technically speaking, it's not the maximum velocity, is it? Because, you know, positive velocities are greater than negative velocities, but it is the maximum speed because it's the maximum of the absolute value. In other words, remember how we talked about it yesterday? You could think of if the velocity is negative, to get the graph of speed, you just reflect it in the x-axis. You know, it would look like, I don't know, I'm not doing it right, but you get the idea. It would all go up, it would flip over and be up there. So that would be the graph of speed, something like that. Okay? All right. Number 2. At which of the times, t equals 2, t equals 6, or t equals 9, is the acceleration of the particle the greatest? The acceleration is the what of velocity? It's derivative, all right? And the derivative can be thought of as the rate of change, the velocity. That doesn't really apply. I guess acceleration could be defined as the velocity of the velocity, okay? I wouldn't. Or don't forget our original thing, slopes of tangent lines, okay? So at t equals 2, slope of the tangent line is 0. At t equals 6, all right, remember how the slope of a line is also its derivative? So at that point, the slope of the velocity is negative, so the acceleration is negative, I don't know, about not quite 1, but it's negative something. Maybe I'll figure that out here in just a minute. And at t equals 9, at t equals 9, well, that slope's positive. So which is bigger, 0, a negative number, or a positive number? The positive number. So 9 is where the acceleration, between those three choices, 9 is where the acceleration is the greatest. Explain your answer. So explaining it's going to be the tough part. Since acceleration is the rate of change of velocity, acceleration at time t equals the slope of the graph of v of t. In other words, a of t is v prime, or a of 2, a of 2 is v prime of 2. A of 6 is v prime of 6. A of 9 is v prime of 9. So I've just written out in mathy terms what we were talking about with the slopes, right? So at 2, A of 2, or v prime of 2, whichever one you want to keep calling there, call it both, is 0. A of 6. So when I actually took the time to figure out what that slope was, turns out it's negative 3/2. And then A of 9, take the time to figure out that slope, it's 3. Therefore, the acceleration of the particle is greatest at t equals 9. If you can say it properly, you don't have to have the numbers, do you? You can say that acceleration at time t equals 2 is 0 because there's a horizontal tangent line. At the acceleration when t equals 6 is negative because there's a negative slope. And at t equals 9 it's a positive number because it's a positive slope. You don't have to have the numbers to properly answer that question. Okay? But you got to explain it. Either way, with numbers or without. You've got to be able to explain it. All right. We good? Let's try number 3. Over what time intervals is the particle moving to the left? Well, we ought to be old hat at this one. What has to be true about velocity for the particle to be moving to the left? It has to be negative. So where's this negative? Between 4 and 10. Now, including 4 and 10? No, because at 4 and 10, the velocity is 0. That's right. If you included 4 and 10, you'd use brackets. Yep. Yeah, that's conventional notation. All right, number 4. Over what time intervals is the speed of the particle decreasing? All right, think back to our conclusion to situation 4. If the speed is decreasing, what do we know about the signs of velocity and acceleration? They're opposites, okay? So I'm starting off my explanation, and you notice that I do this sometimes where I'll explain first. I do that for 2 reasons. One, I think it makes it easier for you to follow it. But 2, it also gets my thoughts in order. Because don't I have to think this to be able to answer the question? Okay, so if I'm thinking it, I might as well write it down as my explanation. So speed is decreasing when the velocity and acceleration have opposite signs. And I don't think you need to say with this next sentence. I think this is just me to you. I don't think the AP people need to see this. In other words, speed decreases when the velocity is positive and decreasing, or when the velocity is negative and increasing. Now, why would I say it that way? Because if the velocity, let me see. If the velocity is positive, all right, positive, and it's decreasing, isn't the acceleration negative? Opposite signs. And if the velocity is negative and increasing, the acceleration is positive, opposite signs. And I'll tell you why I don't think the AP people need to see that. Judging from what I've done with the people on Saturdays and the trainings I've gone to over the years, they like talking about signs, don't they? They seem to really like positives and negatives with signs. I think if we tell them opposite signs, I think we're good. Now, like a question I've answered a few times this week, you know, should I go ahead and write down blah, 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 blah? Hey, look, if you've got time and you can better explain anything you've done, then do so. You just make sure you don't spend 45 minutes on one problem and not get to the rest of them, okay? So if you've got the time to put this further explanation in, I mean, maybe they're looking for it. I don't think so. But I'm guessing. All right, when I tell you what I think they're looking for, I'm just guessing. Because all I can go by is what I've been told and what I've read, and hopefully I'm right more often than not, okay? All right, and by the way, the biggest problem students tend to have on the free responses isn't really writing enough. It's not knowing how to work the problem. That's, you know, that's the big thing, okay? So be able to work the problem, and most of it takes care of itself. All right, so y'all with me? So where are these things happening? Look at your graph. 2 to 4, 8 to 10. From 2 to 4, our velocity is positive and increasing. 8 to 10, our velocity is negative but increasing. So on the first interval, the velocity is positive, the acceleration is negative. On the second one, the velocity is negative, but the acceleration is positive. Yeah. Yes. Yep. Y'all see what he's talking about? Just explain it in terms of the absolute value of velocity being speed, and so you could get that graph, and negative slope means speed is decreasing. Yes, they will take that. No, they don't. If it helps you figure it out, do it. No, I don't think so. All right, number 5. Find the total distance traveled by the particle over the closed interval from 0 to 11. All right, now, we keep coming back to total distance. Total distance traveled equals the sum of the distances traveled between all resting points. And also put in parentheses the absolute values of the differences in position. Because the difference in position could be negative, right? If you're at position 10, and then the next time you come to rest, you're at position, 5, well, then you were going backwards, and you'll get a negative. So the absolute value of that. And this can be done by finding definite integrals between resting points. Sometimes they've given us information where we actually can just kind of find the numbers. They give it to us in a table or whatever. But remember what definite integrals do. They accumulate things. They accumulate what? Well, they accumulate whatever the graph is the rate of change of. So if the graph, the velocity, is the rate of change of position, then the definite integral accumulates changes in position. Okay? Does that make sense? All right, we've run into that a few times, correct? Okay. So, how do you want to break this up? Well, you break it up where your velocity changes what? Yeah, where it changes signs. Okay? From 0 to 4, the object's moving to the right because the velocity is positive. Do I really need the absolute value signs around that when I know the velocity is positive? No. All right? And then from 4 to 10, the velocity is negative. Do I need the absolute value signs around it now? Yes. And then from 10 to 11, the velocity is positive again. Do I need the absolute value signs around it there? No. So why did I put it everywhere? Remind myself and to let the graders know that I know. Okay? Just because it's not necessary doesn't mean that it's not a little bit of an explanation. All right, so find those by finding the areas. So that first is a semicircle. So that definite integral is the area of the semicircle. So it's 1/2 pi r squared. So 1/2 pi times 2 squared. All right. From 4 to 10, it's a triangle. So it's 1/2 base times height. And you don't have to get too fancy here. All right. The base of the triangle goes from 4 to 10, so it's a 6. The height starts at a vertex perpendicular to the base. That's also 6 spaces. I don't have to worry about putting a negative on there, do I? Because I'm taking its absolute value. So 1/2 times 6 times 6. And then from 10 to 11, it's a triangle again, 1/2 base times height. Add them all up. If this was in the calculator section, you might want to go ahead and make that a decimal. But on the other hand, do you have to simplify numbers on the free response parts? You don't. I don't know. They might take this as the answer. They might. I wouldn't. I wouldn't. And I really don't. Surely they want you to do that. Surely they do. And stop calling me Cheryl. Number 6. Find the value of the integral from 0 to 11 of v of t dt and explain the meaning of this integral in the context of the problem. Let's explain the meaning first. Are we going to get the same answer that we just did for finding the absolute value of each little thing? No, because not absolute values, meaning the signed areas are truly signed areas. There's going to be one of them negative. The one in the middle here, that's going to be negative. So first of all, our work can be easy, right? We've already figured out the numbers. Okay? So if it's not the same thing, if it's not the total distance traveled, what does this integral accumulate? Yeah, changes in position, right? Velocity is the rate of change of position. So without taking the absolute value of it and making it speed, with keeping it just velocity, it is accumulating changes in position. So it will tell us the amount of change from the beginning to the end, which could very well be negative or 0, couldn't it? Okay? So the integral from 0 to 11 of v of t dt represents the net change in position or displacement. I haven't seen them use the word displacement, so I would just stick with net change in position, or you could probably just say change in position. From t equals 0 to t equals 11, and then you see the number work there. Yes? Hmm? So, as you're writing that, let me remind you that those two integrals accumulate two slightly different things. The one when it was the absolute value of velocity, or how about we just call it speed, because that's what absolute value of velocity is. It's accumulating changes in position, but they're always positive, aren't they? Or at least they're always non-negative. So it doesn't give us the total, the amount of change. It gives us the amount of distance traveled. Whereas with the second one, where it's just the integral of velocity, we're accumulating the true changes in position, not the absolute values of the changes in position, just the changes in position. So it just gives us the amount of change. Okay, and I'm trying to not use the word total amount of change because I don't want you to confuse that with total distance. But it gives you the amount of change in position that occurred from 0 to 11. All right, so you get the nuance there? All right, last question for this problem. Number 7. If the initial position of the particle is x of 0 equals 2, find the position of the particle at time t equals 11. Ooh. No. Think back to our functions defined by integrals and our fundamental theorem of calculus work. If I write a definite integral from, let's say, 0 to 11 of a function, in this case b of t, and then with the proper notation dt, according to the fundamental theorem of calculus, doesn't that equal the antiderivative of v evaluated at 11 minus the antiderivative of v evaluated at 0? Do we know that value? Yes, we just found it. Do we know this value? Yes, they just told us. So can't we solve for the value at x equal, or at t equals 11? That's what we're going to do. So if x prime of t equals v of t, then the integral from 0 to 11 of v of t dt equals x of 11. That's just awkward to say, isn't it? X of 11 minus x of 0 by the first fundamental theorem of calculus. I doubt you even have to tell why. But it doesn't hurt because I know, right? Therefore, then all I did was add x of 0 to both sides so that I can solve for x of 11. So therefore, x of 0 equals the integral from 0 to 11 of v of t dt. Did I say equals? Should have been a plus. I don't know what I said. Equals x of 11. They told us that x of 0 equals 2, so we substitute that in for x of 0. We found out in number 6 that the integral from 0 to 11 of v of t dt is 2 pi minus 16.5. So simplify that, and we have x of 11. Isn't it just crazy how it all ties in together? Well, hopefully it's not too crazy. I mean, it's supposed to, right? Okay. I do find it kind of neat that they're able to, and this is why you really can't review for the AP test until you've covered the stuff, is because they find a way in motion to bring back the first fundamental theorem of calculus. All right. So until you've covered both those things, you can't review for questions like this for the AP test. All right. So, any questions?